5, 4, 3, 2, 1, 0.
Hello, hello, hello. Guten Tag and здравствуйте. The dog is in, and welcome back to the Element Showcase. So today we're talking about bismuth, and here is one example of it. This is a cubic centimeter of it. This is also how bismuth can look, but I would say that a great way to describe bismuth is how Tom from Explosions and Fire categorizes it. He categorizes it as a
relatable icon element because it forms rainbows all the time, doesn't like to be straight, and is incredibly dense.
Now, all joking aside, bismuth actually does form some very beautiful crystals. Here's some B-roll of it. You can actually see here how they form these kind of cubic hopper-like crystals. So I'm just going to actually let this roll for a little bit, and if you want a full slideshow of all of my crystals, then check out my socials. You didn't just come here to watch me show off my crystals. You came here to see how do you make the crystals and what sort of reactions are there with bismuth. So here's some bismuth, and we're going to melt it down, and we're going to try to grow some crystals out of it using this to heat it up. So now we have to do a slag scraping, which basically means getting all that gunk and stuff that's on top of the metal off. That way it doesn't act as a nucleation site for the crystals. We want the metal itself to be its own nucleation site for a crystal, not the slag. Now, another property of bismuth that you will see here is that bismuth has an extremely poor thermal conductivity. What does that mean? It basically means it does not retain its heat very well. So you'll know, like other metals, if they're out in the hot sun, they'll stay warm for a very long time. Bismuth does not do that. Bismuth actually, I think, has the second lowest thermal and electrical conductivity of any metal. So what that means is that I have to now remelt it and keep it hot, because the only way you can make crystals is through a slow cooling process. If the metal cools too quickly, then it doesn't have enough time for the crystals to form. Crystals take time to form. So again, I do another slag scraping. So after cooling for a little bit, the crystals started to form, and now all I have to do is pour off the top layer of the liquid metal, and this is what we're left with. These are a couple of pictures of the bar after they've been taken out of the mold. So after all was said and done, this is what was left of the original bar. I kind of broke some of the original bar off to make some other crystals with it, and it was actually quite easy. Bismuth is actually quite brittle. You'll notice that with these pictures there are some like chunks and sort of cleavage markings from when the metal was broken. And then there's this small little bit of metal crystal that I made. You can see it compared to like a quarter or a 10-pence coin. And another interesting thing about bismuth is, did you know that it is actually radioactive? Yeah, that's right. You heard me correctly. There are actually no stable isotopes of bismuth. Bismuth is actually radioactive. So let's see what happens when we put some next to a Geiger counter. Okay, maybe I was a little bit less forthcoming. You were probably expecting to hear something more like this. And the reason you didn't hear that is because bismuth 209, the most prevalent bismuth isotope, has a half-life of 2.01 times 10 to the 19 years. That is 20.1 quadrillion years. And also compare that to its radioactivity, or decays per second per kilogram. Bismuth actually won't register on a Geiger counter, at least above background, because of how weakly radioactive it is. So yeah, bismuth is technically radioactive, but it isn't really that radioactive. Now, as far as reactivity goes, bismuth is actually fairly unreactive, surprisingly. Here I was trying to do the nitrated salt, specifically in this case sodium nitrate, the same demonstration I did with the calcium in my last video. And the only thing that happened was the nitrate decomposed. The bismuth itself just oxidized. It didn't actually flare up or anything like that. So this was just basically me trying to fan a huge hot flame on it. The orange color you're actually seeing is from the sodium, not from the bismuth itself. Bismuth forms I believe, more of a teal-ish. It's similar to zinc's flame color, I would say, but all that orange that you're seeing is actually from the sodium. This right here is what was left over after I did that, so I decided to take this and just hit it with a torch to see if anything would happen. And it did. So if you notice, as I'm hitting it with the torch, you'll see bismuth start to reform. That's because bismuth is actually so unreactive that if given enough energy, the ionic bond it forms with oxygen will actually break, revealing the bismuth underneath. Now, because the bismuth is still so hot, it's still prime for reacting again with oxygen. So that's what this does here, forming bismuth 3 oxide. And so, yeah, bismuth as far as reactivity is not very strong. Well, I hope you enjoyed that video on bismuth. This is the doc saying goodbye. Auf Wiedersehen. Do svidania. Thank you everybody so much for watching. Please do not forget to like, comment, and subscribe. And as always, I will see you in the next video. Ta-ta for now.